Okay, I think we're probably right to get started, Celine. It's just past 3:30. So welcome to this session, everyone, on the automated decision support tools for scientists and their end users. Before I begin the session, if I can just acknowledge and pay my respects to the Yugambeh language folk for the Gold Coast and the various lands on all the countries and places from which we're present today, and to their elders past and present. And we've got 3 speakers for this session, and each one of them will have a 20-minute envelope to talk and then questions and answers. If you've got questions, it would be great if you can post those in the chat as we go, but we'll also have some time at the end for you to raise your virtual hand and we can ask questions that way. I'm not sure of the order, but what we've decided to do first is to let James go first because he's waiting up until the wee hours of the morning for us, and then Anna, and then we'll finish with Cyril, who's just waking up and waiting for the sun to rise. So James, I'm going to hand over to you. James is the Research Director of Complex and Social Systems at 26 Technologies, and he's going to be speaking to us about the NLP pipelines for knowledge discovery. Thanks very much, James.
Great. Thank you for the introduction, Paul, and thank you for having me at the conference. I know I'm on Eastern Standard Time, so it just crossed midnight where I'm at. So apologies if I feel or if I sound groggy. I'm normally on the same time schedule as my daughter, who's 3. So this is probably the latest that I've been up in about 3 years. So thanks again for the opportunity to present here. I'm going to try sharing my screen. And I want to make sure, I am getting a Zoom system preference error, so apologies here. And apparently I'm going to need to restart Zoom. So just bear with me a moment, I will be right back.
So that seems to be par for the virtual world. No matter how carefully you plan, something can always go wrong. While we're waiting, can I just get a show of hands of people who wanted to stay afterwards? We've got a half-hour session at the end where if you wanted to go into a Zoom breakout room with the 3 speakers, we would have 3 separate rooms for people. If you're interested in one of those, can I just ask you to raise your virtual hand using the reactions button? I'll be able to see how many people are interested in staying on. Right, so either nobody is listening to me or no one wants to stay on afterwards, or you want to wait and see what things are like first of all before you make a...
It's possible that with the security settings that people can't. I'm not sure.
Okay. Alex wants to stay on. Okay. So thanks, Alex. Okay, we have James back. Back to you, James.
Oh yeah, thank you so much, and sorry for the technical difficulties. I'm on a loaner laptop because my other one sort of broke down earlier this week, so I'm still resetting a couple things. Folks can see my screen. And then could I just test a slide advancement? So that worked as well?
All good.
Excellent. Okay, thanks so much. Yeah, so thank you, Paul, for the introduction. My name is James Gentile. I'm a research director at 26 Technologies, and we're a private firm based in Washington, D.C. that does a lot of research for various government contracts. The work that I'll be presenting here was in support of a program for DARPA called SCORE. And the SCORE program is really looking at developing tools that can automate the assessment of replicability and reproducibility in science. So one of the objectives of the program is to build a suite of machine learning models that can capture what the features and the decisions that subject matter experts use when they're evaluating a manuscript for replicability and reproducibility. And within this program, my team has been building a suite of natural language processing a suite of natural language processing tools that can be built into a variety of different pipelines. And what I'll be presenting here is these pipelines configured for the task of knowledge discovery. So what I mean by knowledge discovery is a standard exercise I think that we all as researchers have done in the past. And that is if you're investigating a new problem or setting up a new experiment or just looking into state of the art, we would generally approach a standard knowledge discovery tool that has indexed to corpora, like Google Scholar, like Sightseer, or some of the discipline-specific indexing utilities, and type in a search term. And these tools have then taken a bunch of papers, mined them, and then sorted them by keywords and by the appearance of terms in these papers. But these tools don't really have a sense of, let's say, what's particularly relevant to a search term or what's particularly high quality research. So what we want to do is build tooling that enables researchers to quickly sift through what is relevant to the research that they want to do, and then also to highlight the manuscripts that are probably of higher quality, meaning that the results presented or the argument presented seems to be a little bit more legitimate than other papers within the corpora. So how do we do this? This is an illustration of our pipeline, and it's got several steps in it that we'll sort of unpack. And each step uses advanced natural language processing tools. So we've seen these BERT-based natural language processing models be deployed in a variety of spaces, and also that these types of models have been applied to a lot of science-specific types of questions. But I think this configuration is particularly novel. So what our tooling does is it takes in a PDF and it performs semantic analysis on the words or the sentences in the manuscript. And what that allows us to do is read the paper sentence by sentence and determine which sentences outline the research claims in the paper, which sentences are describing the methods that the researchers use to evaluate, say, their research claims. Also identify which sentences describe the experiments, the results, and the discussion. So what this gives us is a really handy outline then of a paper. So what's the paper saying? How are they testing the claim? What's the experiment? And then what are the results? And then how have they sort of stitched this argument together to support, say, a research claim? Then each element of our semantic analysis is passed through an automated information extraction model, which allows us to identify the experimental factors that are outlined in research claims. It allows us to determine what qualitative and quantitative results may be supporting the conclusions of the paper. Also look into, say, how many participants were used, how those participants were selected, all these kind of features. And what we can do then is take the outline of our paper and couple it with the information that was extracted from those various semantic elements and build an argument structure for the paper. And what this allows us to do is present then or analyze how well, say, a particular experiment coupled with a particular result supports a claim. And then with enough training data, we can take these graphs, featureize them, run them through a model, and then come up with an overall quality score or confidence score for the paper. So there are the big components of the analysis that I want to kind of talk about in this slide, or sorry, in this presentation, is the semantic analysis and the information extraction. And then I'll show you how we're able to actually build a tool that indexes off of the information extraction elements to enhance the knowledge discovery task for researchers. Here's an illustration of our semantic analysis in action. So our tools were given a paper that looks at the effects of mindfulness interventions when in terms of dealing with the anxiety of the COVID epidemic. So as early on with the COVID-19 epidemic, there was a lot of lockdowns, and this paper wanted to study how well mindfulness exercises could reduce the anxiety that was induced by these lockdowns. So we can take this paper and run it through our model and automatically identify what the research claim of the paper was. And we see that this paper examined whether or not a mindfulness intervention would lead to reducing anxiety during 10 days of the exercise. And we're able also to automatically identify the methods of the paper. So here we see a method by which the researchers evaluated this particular research claim. And we can sort of we go a little bit further by identifying the experiments, the results, and the discussions. And what we can then do is take each of these elements and put them through an information extraction tool, which is able to, given a sentence, identify the experimental factors that are introduced in that statement, and then also identify the qualitative relationships among those factors. So what we can do is give our model a statement like levels of social support for medical staff were significantly associated with self-efficacy and sleep quality and negatively associated with the degree of anxiety and stress, and see that what we're able to do is extract levels of social support as a factor from the statement, and then determine also that the levels of social support had a positive qualitative relationship or association with sleep quality, and a positive association with self-efficacy, and a negative association with the degree of anxiety and stress. So what this allows us to do is take this rather dense statement and unpack it in terms of factors and then the associations with factors. So what factors may positively relate to one another and negatively relate to one another within this statement. And there's more details of the information extraction tooling on the paper listed on the slide. And what we have now is an enhanced outline of the paper where we have claims, methods, experiments, discussions, all that. And we also, for each of those elements, understand the experimental factors as well as the quantitative and qualitative features that are outlined in each of those elements of the semantics of the paper. And what we need to do then is take all of those statements and sort of combine them in a way that gives us a scientific argument for the manuscript. And we do that with argument structure generation. And what we do here is we take various levels of claims in a paper. So say the abstract hypothesis, the concrete hypothesis, the methodology, the experiments, and the results. And what we need to do is link these statements together with one another to provide a full thread that represents a scientific argument of the paper. And the way we do that is by taking each of the elements of the paper and then using standard sort of NLP sentence embedding, measure the distance between, say, the objective and all of the conclusions, and then sort of do a greedy linking to generate an argument structure. And this provides, what this slide is showing is how we generate these argument elements using PubMed labels. So PubMed is, a vast data set, largely of medical literature. And what we ended up doing was using a bunch of PubMed abstracts to train models that are able then to link elements of scientific literature together. And we do it with a decent accuracy, if you can see on this slide. So what I want to do actually is take everybody on a tour now of the tool as it sort of is built today. So here is, can folks see my slide? And I can pause here if there are any questions in the chat. I'm sorry, I can't follow those.
Yeah, you're fine, James. Thanks.
Okay, fantastic. So what this website is demonstrating is sort of the uh, the knowledge discovery pipeline that I just presented on as applied to 2,400 academic papers that were used in this particular DARPA research program, or for phase 1 of this particular DARPA research program. And what we ended up doing was running each of these 2,400 papers through our scientific pipeline. So for each paper, we have an automatically identified argument structure for that paper. And then for every element in that argument structure, we've extracted the experimental factors. So what are the researchers claiming to test within their manuscripts? And we index off of just the experimental factors. So instead of approaching in a knowledge discovery tool that would just index off of keywords, what we're giving, or what we're providing, is a knowledge discovery tool that indexes off of the experimental factors that the researchers are actually using in their tests. So what we can do is look in here, and we can type in any word here, and if there is an experimental factor hit within the corpora, then we'll see some detail from those manuscripts. So I'll just use a standard demonstration that we like. So I put in bilingual. So in this case, we are researchers that are interested in, say, how bilingual folks that speak multiple languages, how well they perform in various language tasks. So what we can see here are that there are 3 related articles that have bilingual as a research factor. And in some of those, bilingual is actually listed within the title of the paper, but in some, the bilingual is not actually listed in the title of the paper. It may be implied within the title. So here on this paper, we can see that the main factors from this study, the effective speaking a minority language at home on foreign language learning, the main factors that our pipeline has identified here are bilingual groups, gender, age, parental education, capital culture. So you can sort of see from this, you can have a guess of what's going on within this paper. So they probably have, groups that speak different languages, of different ages, of different genders, of different education. And then we also identify the main hypothesis that we located in the paper. The main hypothesis here is that despite the general positive association between immigrant bilingualism and foreign language, they expect that this particular pattern is different. So what this paper is doing is looking at lexical recall of bilingual individuals. And the main result of the paper here is that regression, you can kind of read that there. But what I wanted to highlight here is the argument structure that our tooling was able to identify. So this provides a summary of what the paper is actually studying, and this argument structure was automatically extracted using our natural language pipeline. So we can see here that it looks like they were looking at the frequency of lexical recall, and then the statistical results here look at the comparison of Mandarin English speakers and Spanish English speakers, and it indicates that, sorry, I'm having a difficult time reading. In these cases, that Mandarin English bilinguals are about 750 milliseconds slower than folks who speak just one language at lexical recall, while Spanish English speakers are about 800 milliseconds slower. Then what we can see here as we scroll down is our algorithm scoring on the likely replication score and repeatability score of this research, and then an overall research score. So just given the output of this model, this paper doesn't actually look that great. And we also give a breakdown about why this particular paper doesn't look that great or why our models have decided that this paper doesn't look that great. Apologies if one of the authors is on the line here.
So James,
so we
would need to be winding up pretty soon.
Okay, sure. Yeah, so I think what you can see here is it shows that the paper was moderately difficult to read. That there were a lot of hypotheses claims, but very few research claims that we identified. The population size was large, and that all of the p-values were sort of a bit high, which may reflect the poor score. And then we also provide a semantically highlighted manuscript below. And with that, I can wrap up.
Great, thanks very much, James. That's really interesting stuff. I'm a systematic reviewer and would love to use those tools, but there's no questions in the chat, but the one I think is probably on a lot of people's minds is validation of the tool against, say, a human who's doing the same thing. Have you done studies of that, or are you planning them?
We are planning studies of that. So what I can say is it's difficult to get two subject matter experts to agree with one another. So as we all know, right, if you have 3 reviewers looking at a paper, you probably have 4 responses. So it's difficult to evaluate the accuracy of these models when subject matter experts don't always agree with one another, because that ultimately is the ground truth.
Sure. Yeah, robot reviewers has done that by getting 2 experts to look at it, and then they work out their disagreements, and using that as the gold standard is one way of doing it. I think we've got time for one more question, and then we'll probably have to move on. Did anyone want to raise their hand or type something into the chat for James? Otherwise, we might let the questions waft into the discussion session at the end, or James, you might actually be heading, oh, sorry. Did you say the p-value influences the score, from Adrian Barnett?
Yeah, so our models incorporate p-values several ways. So one of the things we look for is signals of p-hacking. So if the p-values follow a particular distribution, it may indicate that the authors are actually doing some p-hacking. Otherwise, we can extract the p-values from the statistical results and then use those as indications of quality or confidence.
Okay, thanks very much, James.
And yeah, thank you, Fiona, for the Replicat call out. I didn't know if I could say that or not, so thank you.
Okay, and there's a couple of comments from Austin that you might want to read as well, but thanks very much, James. So we'll let you go to bed if you want to now, but thanks.
I'll hang out for the session. Thank you. Okay,
great. So we're going to move on to the second presentation. Anna Scott, who's a systematic reviewer here at the Institute of Evidence-Based Healthcare, is going to talk to us about designing and visualizing efficient literature search strategies using the Search Refiner. Anna, over to you.
Thanks very much, Paul, and welcome everybody, and thank you very much for joining us. So just 1 second, I'll share my screen. Can you see that? Thumbs up or a wave? I can't see any of you, so I'm assuming you can actually see this.
Yes, but it's not in screen show mode, Anna.
1 sec, we can do that.
Yep, all good.
Excellent. So I'm going to turn off my video just not to distract anybody. So again, welcome and thank you very much for joining us. And thanks very much, James. That was a really interesting talk. So my name is Anna Scott. I'm an epidemiologist and a systematic reviewer, as Paul said, at the Institute for Evidence-Based Healthcare. And I spent a lot of time doing systematic reviews, so how efficient and how good a search strategy is matters a great deal to me and to many of us on this at this conference, I'm sure. And I'll talk specifically about the Search Refiner, which is a tool for designing and visualizing efficient search strategies. So just very briefly, I'll talk through very, very briefly about evidence syntheses and key steps in evidence syntheses, just to sort of situate this talk and the importance of designing a search strategy and in particular refining it so it's nice and tight. So multiple types of evidence syntheses exist. The general idea is to synthesize the evidence as advertised, or to collate all of the relevant information or studies that address the research question of interest. And there have been heaps and heaps of different types of evidence syntheses devised and categorized. Literature review, of course, we all remember from the first chapter of our dissertations, may or may not be a very comprehensive search. Scoping reviews, conversely, generally try to map all the evidence on a specific topic, so they generally do tend to be very comprehensive when it comes to searching. Rapid review may or may not be comprehensive search. Again, because rapid reviews omit some of the methodological steps of a full systematic review, they may omit, for example, searching multiple databases and stick to searching just one, or they could omit other steps of a systematic review and in fact search multiple databases. Systematic reviews, that'll be the focus on what I talk about, but again, a lot of what I say will apply to other types of evidence syntheses that conduct comprehensive searches. And that's, again, one of the hallmarks of a systematic review, that the search is very comprehensive and it aims to identify all of the studies that address a specific question. And finally, overviews of reviews, which take as their subject systematic reviews. So it's a systematic review of systematic reviews rather than a systematic review of primary studies. So this is the sort of the visual presentation of where we're situated. So when you do an evidence synthesis, of course, you start by identifying the issue or the question that you're trying to answer. Formulate it in systematic review, using that as an example, usually in the PICO format, so population, intervention, comparator, and outcomes, as well as the study types of interest. Plan the protocol. Again, this will apply to systematic reviews, less so to things like literature reviews. And then comes the interesting part, which is the search for studies. And the reason I highlighted both the search for study steps and the screen and select study step is because, of course, the size of the search will directly impact on the amount of work that will have to be done during screening. And I know Cyril will talk a lot more about that in the next presentation. And of course, there's a lot that happens afterwards, but for the purposes of this presentation, we will not focus on that. So why do we care? Well, there is a rule of thumb that says that a systematic reviewer can screen about 100 titles and abstracts in an hour. So if you have a really friendly search librarian who only found you 100 references for your question, it'll take you 1 hour to screen through them, or 2 hours if you've got 2 people screening through them, as you should in a proper systematic review, doing this in parallel. 1,000 references, going up to 10 hours, or 20 person hours, again, if done in parallel. And by the time you hit 5,000, you're looking at 50 hours, so more than a standard work week, and double that again if you're doing 2 people. So when you're designing a search strategy, you want to make sure that it's a good one. Pick your topic wisely, of course. Nice and tight is a good idea. Identify the validation set of articles. So this is something we standardly do. And basically what that means is that we identify several studies that we know would be includable in our review. So they would pass through the title abstract screen and very likely also the full text screen. And we use that to generate the search strategy. So for example, we run the set of validations articles through a word frequency analyzer to pick out obviously the terms that come up the most often. And those seem like a really good idea to use in your search. Drafting a search strategy, we usually use it in PubMed, and when I say we, I usually ask somebody who's a librarian or a specialist to do this. And then once we have a draft strategy, we refine it to make sure it finds not all and only the includable studies, but ideally all and mostly includable studies. And then once we're finished and we're happy with the search strategy, we translate it, of course, to other databases, because in a systematic review, we search multiple databases. So this is the working example I'll use for this presentation. This is an actual systematic review that we conducted about 4 years ago now. And we were interested in acne specifically. So our population of interest was people of any age or gender who had acne of any severity. And we were interested in interventions that were light therapies with blue light as the major component. So the various kind of face mask or laser-ish type therapies. We compared that to any other intervention in light, so placebos, topicals, antibiotics, etc. We had a bunch of outcomes that we were interested in, and we were only interested in including randomized controlled trials. And the reason why P and I are highlighted in red is because those are the terms that we usually use to structure search strategies. So here's the draft search strategy that we started with. So in the upper paragraph is the P, or the population part of the PICO. So we identified from the validation set that the term acne vulgaris recurs, and it's a mesh term in PubMed. And we looked for a bunch of synonyms that also occurred in those papers. And as you have it there, it's acne, blackheads, etc. And we did the same thing for the intervention part of the PICO. So phototherapy is the mesh term, and then we used a bunch of synonyms that recurred in the validation set of the articles. So that was our first draft. Now, if you run this through PubMed, and I did a couple of days ago, you get just over 11,000 results. So if you take that rule of thumb of 100 articles screened per hour, one person's looking at 112 hours of screening, so it's about 3 weeks of doing screening and nothing else. So that's a lot of work. And if you can avoid it, hopefully you don't have to. So what we use is a tool called the Search Refiner. And this is a tool that was originally designed by our colleagues at the University of Queensland, Harry Sells and Hang Lee. And since that, there have been refinements and updates to the tool in collaboration with the Systematic Review Accelerator team here at Bond. So Connor Forbes, who's here with me, as well as Matt Carter and Justin Clark, working together with Harry and Hang to refine and update and make it even easier and better. And at the bottom, you have the 2 URLs where the tool is available. So to use the Search Refiner, you'll need 2 things. The first thing is the draft search strategy, which I've already shown you. And the second is the PubMed IDs for the validation set of the articles. So here is one of the articles in the validation set that we used, which was by Christina Antoniou. It was a randomized trial of blue light phototherapy for the treatment of acne. And you see in the bottom left-hand side, there is the PubMed ID for that article. And we identified the PubMed IDs for all of the other articles in the validation set. And this is what they are. So we used 10 articles in the validation set. There is no hard rules about how many articles you need in the validation set. If you ask our search specialist, that's Justin, he prefers to have 10. He doesn't always get 10, but ideally it's somewhere between 5 and 10. So I'm going to attempt to demonstrate the use of the Search Refiner, and literally an hour ago, the network went down. So we'll see how well that works. So let me just switch to share. I just did something. What did I just do? There we go. Just your screen. Okay, so I have in, I hope you guys can see the Word document. So I've set aside the PubMed IDs for the 10 articles in my validation set and the first draft of the search strategy. So I'm going to put it through the Search Refiner, which sits, as I said, one of the versions sits at the Systematic Review Accelerator, which is our suite of tools, and the other one sits at the University of Queensland. So when you go to the Systematic Review Accelerator site, it looks like this. I go to Search Refinery, I enter the PubMed IDs, Go back to grab my search strategy. Oh, it's not clicking. Why is it so scroll? Ah, it's good. There it is. Okay. One thing is that you can either contribute to data collection or not. It's consent-based, so you can opt out if you don't want to. I'm going to contribute. And what you do is you hit visualize. So here's what this looks like. What you can see is that this search in its current state pulls up 11,169 references from PubMed, so quite a bit. And it also picks out all 10 out of the 10 articles in the validation set. Now, if you don't like your screeners, you can leave it here. If you do like your screeners, you might want to make it a little bit slower, so a little bit smaller. So what you see through here in these arms is what each one of the terms contributes to the search. So for example, LED, which is one of the terms that we have in the intervention arm, contributes, having a hard time seeing that, 519,000 plus articles or search results, but it only identifies 7 out of the 10 citations or the articles in the validation set. So what I'm going to do is try and take it out of my search strategy to see if it brings it down a little bit whilst not losing any of the validation set articles. So just delete it here and visualize it again. So what you see is magic at work. So we now still pick all 10 out of the 10 articles in the validation set, but my search result just went down to just under 3,200. So about 70% less articles to screen. But let's say I'm still not happy with that and I want to take it down just a little bit more. So I'm going to have a look at which terms are contribute a whole lot of search results, but don't necessarily pick up all of the relevant citations in the validation set. And Legion seems like a good candidate because it picks up just 353,000 references whilst picking up only 5 of the relevant citations. So let's try and take out Legion, which is sitting right here. And again, I hit visualize, whoops. And I've just gone down to 1,288. And I still pick up all 10 out of the 10 articles in the validation set. And you can keep going with this. The lowest I've been able to get it down to is in the 500s, which is a pretty spectacular result. But even going down from 11,000 to 1,288, which is about 90%. Out is quite a huge decrease. Now, switch back to the, I took a bunch of print screens this morning just in case this thing decided not to work, but thankfully it did. So here's some maths, right? So remember we started with just over 11,000 results, and that would have taken 112 hours for one person to screen, or twice that for 2, so 224. With removing just a couple of terms, we got it down to just under 1,300, which takes about 13 hours for one person, or 26 for 2. So just by playing around with the search strategy a little bit for a few minutes, we saved ourselves about 200 hours of work, which is a lot. So that's the search refiner. And we use it to refine the search strategy in PubMed, but again, in systematic reviews, you usually search multiple databases. So once we're happy with that search, we translate it to other databases. We use Polyglot, and Justin paid me $5 for saying that. Polyglot Search Refiner is another tool in the Systematic Review Accelerator suite. It lives here. And what it does is it translates search strings between databases, so from PubMed to Embase, Sinal, PsycInfo, etc. I think I'm going to stop here. Thank you very much for listening. This is my contact information, and again, all of the tools are free and they live on the Systematic Review Accelerator website, including the Search Refiner, and it also lives at the University of Queensland server. I'm going to stop sharing here. There we go.
Thanks very much, Anna. No questions in the chat so far. Lots of virtual applause. Particularly, I think the dramatic saving in the number of hours that you need to do of work. That's great. A question from Matthew Page. Very impressive and useful tool. Obviously, the validation set is crucial to making work. Have you had a look at to see whether after using the refiner, you managed to identify not just the validation set of articles, but other eligible articles in another systematic review on the same topic? So this is sort of cross-validation, if you like.
So, sorry, I'm not clear. What do you mean on another systematic review? So whether the use of the validation search as a search strategy builder would miss anything? Is that the question?
Yeah, let's suppose, to translate Matthew's question, let's suppose you had 20 studies in a systematic review. You took 10 of them for the validation set to build it. Do you still capture the other 10 that you didn't have in your training set, if you like?
You know, that's the stuff that keeps me up at night as a systematic reviewer. But thankfully, in a systematic review, of course, if you follow the standard Cochrane methodology, you also do, at the very least, the backwards citation search as per the MISIR standards. Of course, we always standardly do both the forward and backwards. So that's your safety gap, and that lets me sleep most nights. But yeah, that's always a problem. And actually, Matt, I think that's a really good idea for a study. If, you know, you're thinking about doing one, we should talk.
Good.
Thank you.
Any other questions? So Matthew says, yes, let's talk. So I have to ask you, the one last question is, Justin's 10, is that just a sense of what you get, what's feasible, etc.? What would you actually like, and what do you do if you've only got one study for your validation set?
So Justin's rules is the more the better. So he says he would like 10. Now, as you say, you won't always get 10, and it'll probably depend on the area and that question that you're asking in your systematic review, how much evidence there is. Because if the entirety of the evidence is 4 studies, which we just had a case like that of a systematic review where the entirety of the evidence literally was 4 RCTs, you ain't gonna get 10 articles in your validation set unless you're getting a little bit broader in terms of what you're including. So perhaps you might get more permissive and say only stuff that would have cleared the title abstract stage, but not necessarily full text. But it's a bit of a sort of, you know, not a hard and fast rule. It's more art than science in the sense that you don't necessarily know this a priori either.
Yeah.
Right? So just do the best you can.
Okay, so more research is needed. Okay, well, thanks very much, Anna. I think you've sold people on doing the talk, but also involving some new research to try and test out some of the ideas. We're going to move on to the last speaker then, and hopefully Cyril's had a couple of cups of coffee now to wake himself up. Our last speaker is Cyril Labbe, a PhD in computer science at the University of Grenoble, and going to talk to us about a fascinating topic that's been worrying us all, I think, in the pandemic, which is trying to find automated assistant to screen scientific literature for problematic papers. And there have been a lot in the pandemic. So very timely talk, Cyril. Thank you.
You're welcome. So yes, I'm going to speak about papers that you don't want to see in your literature review, or that you, well, actually, you won't need James' tool to decide that they are fake or that you crappy or whatever. So the kind of paper we are trying to detect are papers that are completely generated. So you may know this kind of tool. You just click on the button and you get a really nice scientific paper. Well, it's not really scientific, it's completely randomless. The English is very good, but you have strictly, the text has strictly no meanings. And so this one is on Programmatic. It's a computer science paper. but you can generate some math paper, or there is also the data engine that generate, let's say, philosophical paper, postmodernist paper. So this data engine tool has been made in Melbourne in Australia. And so all these tools are able to generate also a graph and a nice figure. And the references are also automatically generated. And they are useful because they can be used. So for example, to create a citation farm. And so you can create a fake, or you could boost your hash index. So for example, here it's a fake researcher called I Can't Care, and it had once a hash index of almost 100. And so because Google Scholar indexed all the papers that were generated and citing each other, so this has been called a citation farm. And so you could generate paper so to boost your hash index. You can also pad your CV using this kind of generated paper. So a lot of them have been accepted in first top publisher. For example, IEEE is a very big publisher in computer science, but there was such kind of paper at Springer Nature, for example. And so if you want to pad your CV with this kind of paper, it's a bit dangerous. So you may more use a paper mill. And so Jennifer Byrne, who is around, is used to try to tackle this kind of paper. So we've built together a tool that's called Seek and Blasten, and can be used to check the reagent, how the reagent are presented in the text, to see if they are conform or not to a database BLASTn, using the BLASTn algorithm. So this kind of tool can be used to to detect the paper where there is a factual error. And I would like to focus today on another kind of strange thing that we discovered this year. We call that tortured phrases. And Alexander Magazinov get in touch with Guillaume and me because we met through Papier, because Guillaume and me, we were posting on the Seek and Blasten account. We were posting about the Thygen paper, so the one that are generated. And Alexander Magazinov was also posting on this kind of paper, and he get in touch with us because he found some strange wording in some paper. So I've got a little quiz here. So you can post in the chat. I think I'm able to see it. Yes. So for example, what do you think that counterfeit consciousness mean and made brain power? So any answer in the chat? You don't see what it could be? Yes, it is artificial intelligence. And so we have seen many papers on using this term instead of artificial intelligence. So sun-oriented force. So do you have any idea of what this could be? Yes, solar energy. Pinnacle flag to Clemmer proportions. So you've got the right acronym on the right. So this is peak signal to noise ratio. Credulous Bayes would be a classification scheme that is called naive Bayes. Then we can find some boson malignancy or boson peril. This will be the chest cancer employed. So all these terms are employed in some paper instead of real scientific terms. So for example, nucleic corrosive enhancement tests will be amplification test, and extreme intense respiratory disorder would be the SRAS. So all these strange, so Alexander came with a list of very strange terms that we call tortured phrases and can be seen on the left column, and with the correct expression on the right column. So we issued a preprint. You've got the link here at the top, and so there was quite a lot of let's say reaction to this preprint. But we asked ourselves why this kind of strange sentences could come in the scientific literature. And we came out with 3 different explanations for this kind of tortured phrases popping up. So the first one is the use of machine translation. So if you use a text in English, translate it in French, and then back from French to English, and maybe the automatic translation will generate this kind of strange wordings. But it turns out that doing a small amount of experiment, we don't really see this kind of strange wording coming out of this process. Another thing that is used by students to avoid plagiarism checking is what has been called spin boats. These are automatic paraphrasing tools that can be used to change the text, and most of them, for some of them, the oldest one, just replace the terms by synonyms. And using this kind of tools, you can generate completely strange wording. So so now we think that the way these strange tortured phrases are generated is through this kind of spin boat, where the text does not be reread after the spinning, and so these tortured phrases are along the text at plenty of places. A third possibility would be generation from a few words. So this is something that that is very funny. You just there are tools online where you can try the new model language that are quite famous nowadays. So based on transformer, so on machine learning techniques that are quite up to date. And you just type a beginning of a sentence, and then the text is generated for you. So this also could be a way that has been used to generate the text that we see that are completely meaningless. So we use a detector that aim to detect the texts that are generated automatically, and we find out that this detector is working pretty well on the texts that contain tortured phrases. For example, here on the green box, you have a text that is pretty nice. So, for example, it speaks about random forest classifier. So it's not a naive-based classifier; it's a random forest classifier. And then, being spinned, it turned to be arbitrary timberland arrangement. And so we find this kind of red text in what we call lazy survey, because people just took abstract of paper, put them in a spin boat, and then glue them together, and then they've got a nice review paper, literature review paper. And so it turned out that this kind of texts are popping up quite easily with a GP2 detector, and so we use it to process systematically the paper of one journal that is from Elsevier, and it turned out that plenty of these papers are containing strange text or tortured phrases. So we did an editorial assessment of this journal and what we found is that the time from submission to publication has drastically fall down. So the time is very, very short. And so this may explain the fact that plenty of paper are coming in and are published, and most of them are really crappy. And that's a lot of paper to assess, in fact. So and we are really, we want the paper to be assessed by human, because so we could let the detector run and flag automatically all the paper. But this is something that is very important for us, that the human assessment after the tool assessment. So this is something that that is also done for Seek and Blast, but Seek and Blast is doing much more error than the GPT detector. But still, the human validation is seems very important for us. So Guillaume, so we decided to put online a tool that is called the Programmatic Paper Screener. I will put the link in the chat after, and you will have the slide anyway. And so you can find at this place the list of paper that has been assessed by some people, but also the one that has not been assessed for yet right now. And so you can click here, for example, and then you will be able to see the paper and try to assess it. And then the way to deal with that, when you see that there is a problem, there is kind of two ways to do that, to address the problem. One is to go to the editorial team or to the publisher to signal the problem. And the other way is to post on PubPeer. So for each paper here, you can see if there are already posts on PubPeer regarding this particular paper. So a lot of people have used the term torture phrases right now. So so Elizabeth Bick used it. Nick Wise is also someone who posts a lot on PubPeer, and he has used the torture phrases, and I think he is using the PPS, the Programmatic Paper Screener, to find out the paper that he wants to publish on. We are also using this this tool in another project, and so this tool has been quite visible. We had a lot of feedback on it. So Nature published 3 news regarding this this tool. There has been a lot also on Retraction Watch, because a lot of paper have been retracted, and there is also the work with Jenny. So the paper that contain torture phrases, or the papers that are generated, they are not really harmful, in the sense that maybe they will just overload your screener or your literature review tool, but they will not introduce real error in the literature. And the paper that Jennifer Bean is looking after are really more problematic, because they are really introducing error in the literature that can be after that picked up by other people or automatic tool. And so just would like to end my talk by saying that this is an ongoing process. So with this invitation for human assessment, so it's a kind of helping the open peer review by providing people entries where to potentially programmatic paper. So it's trying to use the power of the crowd together with the machine screening. And so you can follow Guillaume on Twitter, or if you are interested in having more information on following up the thing. So Guillaume on Twitter, Jennifer Bean also, the nanobubble team, working on a subject that is more broad. So how, when, and why science failed to correct itself, and try to understand this process of autocorrection. And then the group, automated screening working group, that provide a set of tools to assess paper, the kind of tools James presented us a few times ago. That's in this session. Okay, thank you very much. I think I'm done.
Thank you very much, Cyril. Amazing work, terrifying results, I would say. I wasn't even aware that this number of tortured phrases and papers were out there. But as you say, don't cause a problem in people trying to review the area because they're so readily identifiable. But I was wondering, for the broader range of things, are you working with people who do literature syntheses, systematic reviews, to help in an automated way to detect the problematic papers?
I'm not sure to understand very well the question, but so we don't work actually with people that do tools for literature review. Mm-hmm. We are more working with publisher, yeah, because they are afraid of having this kind. It's a bit of a shame for them to have this kind of paper, so they are worried about. So they are looking for tools to identify automatically this kind of paper. But it's true that they could also be integrated in the literature review tool. But right now we don't do it. Yeah.
Right. So
it's a possible kind of collaboration we could have with.
Yeah, so we'll have to talk. We've just been discussing this problem because it's been as I said it earlier, a problem in the pandemic with a number of fraudulent but detectable papers. Anna's posted a question. One more thing to worry about with papers included in evidence syntheses. Yes. Jennifer Burns got a comment. Great talk, Cyril. The detection of dubious papers using tortured phrases seems very powerful. Have you examined whether tortured phrases papers are cited?
So it's something that is very strange. So all this, even the fake paper generated with Cygen, some of them are cited, and the tortured phrases also, some of them are cited. So it looks like there is not only paper mills for publishing paper, but we are in at a stage where we are wondering if there is no also selling citation, if they are not also selling citation. Mm. So yes, so they are cited. So it's not a great amount of citation, but there are citation.
Mm. Okay, fascinating. Would you mind stopping your screen share
yes,
now?
Sorry.
That's all right. And I just wondered, I think everyone should be able to be unmuted now if they want to unmute and ask a question. Preferably raise your hand first, but actually I've got two screens of people, so it's a bit hard to monitor. Jennifer.
Sorry, I don't want to be sort of asking questions over and over, but I think back to this idea of paper mills sort of, or somebody selling citations as well as papers. Is it possible that, I mean, one thing we're looking at is, can the citations themselves give some clue to that? You know, that features of citations indicate manipulation of citations. Not being very clear, but
no, but the citation can come from very, so for example, we had a case where there was generated paper that had real citation to real paper, and plenty of them having citation to small sets of real paper. But we think that it's more generated by the fact that it's a kind of, you know, there is the head of the lab, and everyone cites his paper, but the people in the lab just generate paper to fulfill the bureaucratic expectation. And then the head of the lab, I think, don't read the paper. And then everybody just check that he's cited or something like that. And so then he gets, so I really don't know if they are sold, the citation, or if they are just a kind of effect of people trying to publish crappy things and just checking that they are citing the right paper, and because they know that the paper will not be read, but just the citation will be cited by the editor or by the chief, or I don't know. So it's very difficult to understand how the process of why these papers are coming in.
Cyril, can I ask another question? I'm just curious. I presume that people are doing this for either job application or promotion decisions. That's their motivation, that they need some publication, so they go through this process. Otherwise, I can't see why you'd even bother going through the process. But that, with your tools, you could detect that for a group that was making a hiring decision, for example. So it sounds like you could generate a little business here of offering to universities to detect fraudulent papers that are being submitted for people applying for jobs.
Yes, perhaps. But my motto on this is that the kind of tool we have here should not exist, because the people should not be forced, or there's kind of, well, in an ideal world, you will not be hired because of the number of your publication or because of the number of citation you have, and then if people are strictly relying on this number, then we run into a race between tools to generate and tools to detect the generation and things like that. So yes, maybe we could run in a little company selling detection of strange stuff, but I think Guillaume, me, and Alexander, we prefer and Jennifer also, I guess, we prefer the way that the root of the process is the publish or perish system, or the places where there is a very big bureaucratic pressure where the papers are not read, etc. So these papers are coming from a very specific place in the world. So,
okay. Any other questions that people have for Cyril? Otherwise, I noticed there's some questions coming in for other folk, a couple for James, for example, and if people wanted to unmute them to ask their questions of anyone now.
Sure. Yeah, I can kind of speak to, I think, pardon me if I mispronounce your name, but Zin's question. So I think what he's asking is, so I did mention that we're using natural language processing models that are all BERT-based. And what these models do is they take in a bunch of natural language data and then build a semantic model that allows us to do fun stuff on the output. And some of the BERT-based models for science are trained using computer science and biocorpuses because they just are favored for this type of stuff. And I can say that for our models, we have found that the Spear, if you know that, seems to generate the best embeddings for the type of stuff that we do. Because what we're actually trying to do is link phrases to one another rather than, say, just semantically analyzing one phrase. So we looked at a lot of, we did look at Cyber, we looked at Roberta, we looked at a ton of these, and yeah, so. Did that answer your question?
Yeah. Sure.
Cool. And we've also been, we've demonstrated that these models are pretty good at porting between disciplines. So we use a lot of data in the social and behavioral sciences. We also use a lot of data from PubMed because PubMed is just well curated. And when we train on PubMed and test on the social and behavioral science, we do see pretty good performance.
Okay, great. Thanks,
I think we're currently investigating T5, if you know that one.
Oh.
So, which is another one of these masked language models.
Then I wonder if we need to update this pipeline regularly. I mean, on the backend side for the pre-trained model.
Yeah.
Okay.
And if we're in nitty-gritty NLP land, I did have a question for Cyril. I was wondering if he could forecast how well his tools will do with, I guess, the emergence of, like, you know, these tens of billions of parameter causal LM models like GPT-3 and GPT-J.
I think.
Yeah.
Sorry.
Yeah,
please.
So in that case, I wonder how do you evaluate the performance across a different kind of pre-trained model? Because we also involve a different kind of factors in this pipeline, right?
Yeah. So I'm sorry, my audio was a little hard there. So I think your question was how well we would evaluate how a particular model ports from discipline to discipline.
Yeah.
So the way that we do that is just the outside discipline would be our validation set. So we would train within a discipline and then port. Now, there is likely some SBS studies within our PubMed that we just don't have the bandwidth to curate that well. So there is probably a little contamination there, but overall, I think the PubMed data looks a lot different than the social and behavioral science data.
Okay, great, thank you.
Yep.
So I'm just going to interrupt there and just ask if people wanted to go into the breakout rooms, if you can just raise your hands if you want to speak to one of the specific speakers, one of the 3 speakers during this session. Can you just put up your hand? Jennifer, Fiona's actually clapping, so but she's putting up a hand as well. And Elliot. So what I'm going to suggest is that I'll create the breakout rooms, and the breakout rooms will be in the order of the speakers. So breakout room 1 will be James, breakout room 2 will be Anna, and breakout room 3 will be Cyril. And I think you have about 15 minutes before the next session starts. So I'll just create those now, and everyone else can go and grab a cup of coffee before the next session.
I've created them, I believe. So I think you should choose. I hope I spelled the names right. So I was doing it quickly. Sorry, Cyril, I misspelled your name.
That's okay.
Thank you. Okay, and before everyone goes, thanks to all the speakers for this session. It's a great session. Thank you.
Sorry, how do I join a breakout room?
Same question for me.
Speakers, sorry, the speakers can't, so I have to assign you. I will assign you to your.
So James, what we detect now are really old tools. So with the new model of language, like the transformer, I think it will be more difficult to detect the generated text. So there is effectively a race between the generation and the detection.
Yeah, I have your email. I'll follow up out of. I think about this stuff a lot, so we should chat.
Yeah, I really appreciate your talk and the tool you presented. We have to join the rooms.
Thank you. Bye.
Yes.
Cyril and James, you should have gotten a notification to join your room. Great. Alan and Rod, I'll go ahead and make you co-hosts now.
Sure.
Maybe a little bit more. I don't know if Paul's planning to come back to the main room yet for the end of his session.
And Julia too.
Oh yeah, right.
Hello, everyone.
There we go.
Can I ask, how bad is the rain sound? Can you hear me, or is it quite muffled?
I don't hear the rain, I don't think.
Okay.
Nah. Where are you, fella?
Brunswick.
Yeah, that's right. I thought I saw you the other day.
Oh, did you?
Yep. Almost ran you down.
Well, not hard to miss these days as I like slowly waddle down.
Yeah, you weren't walking as fast as usual.
Yeah, that's right. Rod, I was thinking maybe it would work if you went first.
Who, me?
Yeah, if that's all right.
Okay, sure. That's perfect. Okay. Yep.
And then maybe Julia and Rihanna. Since you are all very democratic about order,